Got trig identities, exercise 6.9. We're just looking at everything we know so far, plus we're going to look at a few more identities. So, reciprocal ratios, cosec theta is 1 on sine theta, sec theta is 1 on cos theta, cot theta is 1 on tan theta. Complementary angle results, cos is sine of 90 minus, it's cos theta, sine of 90 minus, cosec and sec, tan and cot are complementary, and then you can write them the other way round. Okay, we've also got angles greater than 90 degrees. Angles of any magnitude. So we've got 9 of those. Actually, even more. Actually, I might have to do them like this. So angles of any magnitude. We'll do quadrant 2 angles first. Sine of 180 plus theta is just the same as sine theta. Cos of 180 plus theta. Cos is negative in quadrant 2. Oh no, that's quadrant 3 there, sorry. Put minus. Minus tan of 180 minus theta is negative tan theta. They're my quadrant 2 angles. Quadrant 3 angles. Sine of 180 plus theta is negative sine theta. Now, you could always just draw it, you know. So if you're looking at quadrant 2 here, the sine of this angle is sine of the acute angle, etc. 180 plus theta, that's plus. The related angle in that quadrant is theta. Cos is also negative in quadrant 2, and tan is positive in quadrant 2. So when we do this exercise, you can use any of these, any of those, any of these results, right? And then quadrant 4, we're going to look at quadrant 4 in 2 different ways. 360 minus and negative angles. So quadrant 4 is 360 minus theta or negative theta. Remember? If I go that way around. But I can go to any quadrant negative. But it's just that using the quadrant 4 negative one's very common. They don't tend to use the minus 180 plus quadrant 3 negative. But the quadrant 4 negative angle is very, very commonly used. So quadrant 4, the sine of 360 minus theta is what? Positive or negative? It's negative sine theta. The cos of 360 minus, is that one positive or negative? Positive. And the tan of 360 minus theta is also negative. Okay. Sorry, I'll just move this 360 minus theta out of the way. And also in quadrant 4, I could ask you for the sine of negative theta, for example. What's that one? Yeah, it's negative sine theta. Really important to remember this one. So I'm not going to put the negative theta. Well, I'm going that way, so it's negative, but that is negative theta. All right, in quadrant 4, negative theta. And this one, you can't see it properly, but it was 180 plus. That one was 180 plus. And the little angle in there is theta. So sine of negative theta is negative sine theta. Cos of negative theta. Cos is positive in quadrant 4. That's just the same as cos theta. So for example, cos of negative 30 is the same as cos 30. And the tan of negative theta is negative tan theta because tan is negative in quadrant 4. Now they are your angles of any magnitude. A whole heap of them. Okay? Unit circle to come up with expressions for tan theta and cot theta, and then we're also going to be doing Pythagorean identities. Now, if this is a unit circle, radius 1, I know it's not a good circle. This is the center. If this is the point xy, remember we did this before, so x units across, y units up. Remember that, remember we had that sine theta is y over 1, which is y. In other words, y equals sine theta. And we know that cos theta is adjacent over hypotenuse. It's x over 1, which is x. So therefore, x equals cos theta. We did this before, right? And tan theta, we know, is what? Y over x. In other words, so we know that y equals sine theta. We know that x equals cos theta. Therefore, tan theta is y over x. Now, y is sine theta, which is sine theta over, and x is cos theta. So therefore, tan theta, you know this result already, is sine theta over cos theta, but that's how we get the result. And just following on from there, we know that cot theta is 1 over tan theta. Isn't it just cot, or isn't it just, instead of opposite over adjacent, isn't it adjacent over opposite? So it's the reciprocal of that, which is cos theta over sine theta. So the result for cot theta is the reciprocal of the tan theta result. So cot theta is cos on sine. Tan is sine on cos. Cot is the reciprocal of that, which is cos on sine. Now we're just going to look at the Pythagorean identities based on this unit circle. Okay, so Pythagorean identities. So again, this right angle triangle, I've got the point x and y, x across, y up, the radius is 1. We know from Pythagoras' theorem that x squared plus y squared equals what? 1 squared. Yeah? X squared plus y squared equals 1 squared. I know that that length is x and this one's y, and that the hypotenuse is 1. So replacing, but x we know is cos theta from what we were just doing in the unit circle. Doesn't x equal cos theta and y equals sine theta? But x equals cos theta and y equals sine theta. So replacing x with cos theta, therefore cos theta squared plus sine theta squared equals 1. But that's not how you write cos theta squared. You don't write it like that. You actually write it like this. Cos squared theta plus sine squared theta equals 1. We tend to write it as sine squared plus cos squared is 1. It doesn't matter. All right? Now, identity that cos squared theta plus sine squared theta is 1, you don't often, sometimes you use it in that form, but often you will, or rearranging, however, you will often use it when you need to make a substitution for cos squared theta or for sine squared theta. So rearranging, I've got that cos squared theta is 1 minus sine squared theta. Are you okay with that? And starting with that equation again, sine squared theta is what? 1 minus cos squared theta. So you will use this equation here in 3 forms. Often if you see cos squared theta plus sine squared theta, you can just replace it with 1. If you see a cos squared theta, you can replace it with 1 minus sine squared theta. If you see a sine squared theta, you can replace it with 1 minus cos squared theta. Okay? So 3 results from that 1 result so far. Cos squared theta plus sine squared theta is 1. So 2 other identities that can be derived from this result. If I start with cos squared theta plus sine squared theta equals 1, and I divide through by, I'm going to go cos squared theta first. So if I take that one identity, this is the one you need to know. And now what we do with it, we divide it by cos squared theta. And what will that give me? So I've got cos squared theta over cos squared theta plus sine squared theta over cos squared theta equals 1 over cos squared theta. Now, what is cos on cos? 1 plus sine on cos is tan squared theta. 1 on cos is sec. Now, this is how I remember this one. 1 plus tan squared theta equals sec squared theta. I remember it like this. It's, as in it is, it's. 1 plus t equals s. 1 plus tan squared theta equals sec squared theta. It's. That's how I remember it. Okay, now going back again, if I start with cos squared theta plus sine squared theta equals 1, first Pythagorean identity again, cos squared plus sine squared theta equals 1. If you, instead of dividing through by cos squared theta, we divide through by sine squared theta. So dividing each term by sine squared theta, we get, now what's cos over sine? Cot. So it's cot squared theta plus sine on sine is 1. 1 on sine is cosec squared theta. And the way I remember this one, a bit weird, is 1 plus little c equals big C. You know, like something plus something small gives you something big. 1 plus cot equals cosec. Because what are the 6 ratios? Sine, apart from the cos, you have to know cos squared plus sine squared is 1. These other 2 ratios, girls, these other 2 use tan and sec and cot and cosec, whereas the first one uses cos and sine. So let's just write the 3 out again. Cos squared theta plus sine squared theta is 1. Then you could say to yourself, dividing through by cos, I've got 1 plus, if you divide sine on cos is tan, 1 plus tan squared theta is sec squared theta. And dividing by sine, I like to write it as 1 plus cot squared theta, even though it's out of order. It should be cot squared theta plus 1, is cosec squared theta. So they're the 3 ratios. Now, of course, you could rearrange those 2 second equations. So they're the 3 that you need to know. Well, if you know the first one, you can derive the other 2. But also, you can rearrange this one, 1 plus tan squared theta is sec squared theta as well, to write any result that you want. For example, we know that sec squared theta is 1 plus tan squared theta. We also know that tan squared theta is sec squared theta minus 1. You could do that substitution. Okay. We don't tend to use the substitution sec squared theta minus tan squared theta is 1, but you could use it if you had to. Sec squared minus tan squared is 1. That could be rearranged. And you can also rearrange the 1 plus cot squared theta is cosec squared theta as well to make an expression for cot squared theta is cosec squared theta minus 1. So you can rearrange any of those 3 equations however you want, okay? And then we'll do some examples. Simplify sine theta times cot theta. We know cot is cos on sine. So therefore the 2 sines would cancel out. So that's sine theta times cos on sine. Sines cancel out, gives you cos. This one. Oh. So this one, you've got to be careful. Oh no, sine of 90 minus, that's your complementary, is cos of beta. Okay with that? And sec is 1 on cos, the 3rd letter, so they cancel. And you get 1, all right? So 90 minus, always think complementary. Sec, it's 1 on cos. It's the reciprocal ratio, all right? This one. This one involves a factorization. See how you can take out sine? We might just do this. Do you want to do this one? So sine squared theta is a common factor between the first 2 terms. So pulling that out as a common factor, we're left with sine squared theta plus cos squared theta. We know from our Pythagorean identity that sine squared theta plus cos squared theta is 1. So sine squared theta times 1 is sine squared theta, and the square root of sine squared theta is sine theta. Can we try the next one, please? Example 4, prove that cot of x plus tan of x equals cosec x times sec of x. So cot of x. So left-hand side, you always start off, this is how you need to set it out. The left-hand side equals cot x plus tan of x, which equals, what's cot x? It's the, so underline 3rd letter. It's the reciprocal of tan. Don't write it as 1 on tan. Write it as cos on sine plus, because, oh look, you could, I suppose, I don't know, we can try that if you want. We'll try another way. There's always many different ways to do it, right? Plus, tan is sine on cos. Now, look at what you're trying to get. We're going to end up with two different ratios multiplied by each other, and I know that this is 1 on sine and this is 1 on cos. What would you do with these two fractions, do you think? Common denominator. So, the denominator is going to be sine x cos x. So what do we get? Cos squared x. So cos times and sine times that plus sine squared x is that. You okay with that? Common denominator? What's cos squared x plus sine squared x?
1.
So it's 1 over sine x cos x. Now, that means, yes, you can, and with a times. That is 1 over sine x times 1 over cos x, right? And what does 1 over sine equal? Cosec. So that's cosec x times, and 1 over cos is sec x, which equals the right-hand side. Okay, now, that's the best way to do that. But let's say you decided to do it this way. You might get stuck. So when you get stuck, you try another way. Let's say you started off with left-hand side is cot x plus 1 plus tan x. I know cot is 1 on tan x plus tan x. And then you decided, all right, I'm going to go common denominator or something, right? I'm not saying I would do it this way. 1 plus tan squared, well, see how this is not really getting me anywhere? Do you know what I mean? Then you'd have to write this as sec squared x divided by tan x and start trying to play, which is 1 on. So let's say you decided to do this. That's why I'm saying if you're seeing cot and tan, write them out in their full expanded sort of versions. Cos on sine, and because if you do it this way, sec is 1 on cos squared x. Now, divided by tan is divided by sine x on cos x, just seeing what I get, which is times cos on sine, isn't it? So it's just seeing if we're ever going to get there this way. And one of the causes cancels. Oh, you know, it's sort of, you can get there. So one of the causes cancels, doesn't it? So you've got 1 on cos times 1 on sine, which is your answer. Which is sec times cosec, which equals right-hand side. So if you were to do it that way, it does involve a bit more, and you end up doing all this anyway. So this is better. All right. So look, sometimes you have to change the cotton to 1 on tan, and other times you may not have to. Look, there are several ways you can do your proof. Minus cos x over sine squared x equals 1 over 1 plus cos x. Now we're going to start with our left-hand side, which is 1 minus cos x over sine squared x. Now, looking at the sine squared x, that's from the Pythagorean identity of sine squared x plus cos squared x is 1. So just over here I'm going to write, I know that sine squared x plus cos squared x equals 1. That's a plus, right? So can I come up with an expression for sine squared x? Yeah, so sine squared x is 1 minus cos squared x. And did you know that 1 minus cos squared x is not a perfect square, but it's a difference of 2 squares? So that's why we like 1 minus sine squared x and 1 minus cos squared x, because it's really 1 squared minus cos squared x, which is 1 minus cos x, 1 plus cos x. And that's really good to use because one of them is going to cancel with the numerator. So I'm just going to write it as 1 minus cos x over 1 minus cos squared x. Then here, that's 1 minus cos x over 1 minus cos x times 1 plus cos x. And I can put that in brackets now, and we can cancel. And we get that it's 1 over 1 plus cos x, which equals the right-hand side. So please, if you see sine squared, you're meant to use a Pythagorean identity 99% of the time. All right? Side equals 3 plus 3 tan squared theta. What do you think you want to do with that? Yeah, factorize. 3 bracket 1 plus tan squared theta. Now, what does 1 plus tan squared theta make you think of? It's 1 plus tan squared theta equals sec squared theta. Remember, cos squared plus sine squared is the original, and 1 plus little c equals big C is for the other. Remember, there's 6 trig ratios: cos and sine, cot and tan, and sec and cosec, whatever. All right. So what's that? What's 1 plus tan squared? Sec squared. Now, what's sec? Good. So I'll just put that over here. So it's 3 over cos squared. These are meant to be alphas. I've been putting thetas, doesn't matter. And what's cos squared? So over here we write cos squared theta. You always write it this way first, because please don't try and rearrange it without writing it down. People make mistakes. Cos squared theta is what? 1 minus sine squared theta. So I'm just replacing this cos squared theta with 1 minus sine squared theta. And that equals the right-hand side. So the left-hand side is cot theta plus 2 sec theta. All right, what do we do? What's cot? Guys, look at the answer. There's all sines and coses. So let's fix up cot. Don't write it as 1 on tan, because your answer's got all sines and coses. You write it as cos and sine plus 2. Sec is 1 on cos, so it's 2 over cos theta. So what do you think? Oh, we're nearly done. This is easy. What would... Yep, common denominator. Off you go. Cos squared theta plus 2 sine theta. This one's fine. Over sine theta, cos theta. These aren't hard. And you just change. So over here you always have cos squared theta plus sine squared theta is 1. So cos squared theta is 1 minus sine squared theta. So you just replace that. You replace your cos squared theta. Let's try the last one. This result here. So our left-hand side is cosec x plus cot x times cosec x minus cot x. That's a difference of 2 squares. So that's cosec squared x minus cot squared x. Now we know the result 1 plus cot squared x equals cosec squared x. So we can replace, why don't we just replace the cosec squared x with 1 plus cot squared x. So that's 1 plus cot squared x minus cot squared x, and they cancel, equals 1, which equals the right-hand side. Okay? Always a good idea to write that result you need on the side. Here with question 5, show that if x squared plus y squared, show that x squared plus y squared equals 81 if x is 9 cos theta and y is 9 sine theta. Remember, we start with left-hand side. Left-hand side is x squared plus y squared, which equals 9 cos theta squared plus 9 sine theta squared, which equals, you know what to do now? So remember, if you're showing something, you've got to start with left-hand side. So isn't that 81 cos squared theta plus 81 sine squared theta? Now what do? Factorize 81 bracket cos squared theta plus sine squared theta, which is 81 times 1, which is 81, which equals the right-hand side.